Hello there everybody, it's Malcolm Budden here from MNB Networks. Today we're going to go over a short video which explains the network design, core distribution and access model. This model is normally used in the campus LAN, which to most of us that just means the LAN of sites, but it's normally at large sites, and historically it's also been used in the data center environment. Some of the things that happen in the networking industry, specifically to network design, is that we reuse designs a lot of the time, and that is good in some ways, but in other ways it's not so good. The reason why it would be not so good is because if we just done something because we've done it in the past, it might not meet the business requirements, which is what we always try to design against. The business requirements are then used to drive what the application requirements are, and the application requirements in respect to how the applications perform in the network drive the network requirements. So that's not really completely related to what we're talking about today with the campus core distribution access model, but it's a background driver behind it. Let's talk about the campus core distribution and access then, and it typically looks something like this. So if we have some core switches, and that's the core layer, and then we have some distribution layer switches here, and then we have some access layer switches, which we normally have more of these spread throughout the campus LAN. So if we've got 2, 3, 4, 5, 6 of those, and let's just say they're connected like this with redundant uplinks to every distribution switch. You get the idea. And then the distribution switches also have fully mesh connectivity, and then the core. Now, most people watching this video, even if you've just started out in networking, you'll probably have seen some sort of core distribution access model like this before and just went, alright, that's cool. And you'll probably also have read, well, what does this core layer do? The core layer is basically to get everywhere else, but not to get everywhere else, just fast. So we want to get to the rest of the network. If we've got uplinks here to the rest of the network, which might be the WAN or whatever, or the data center, the core layer is used to effectively have high-speed links to these different environments. As we go down the core distribution access layer stack, if you ask the question, well, what does the distribution layer typically do? It normally hosts default gateways. It performs routing, and you'll see in the books, all of the books typically explain that it also is used for services. So when we say services, this is the layer that we normally have firewalls, load balancers, proxy servers, things like that. But anything that's a stateful device, for example. And then finally, we have the access layer, which is over here. And if I zoom out a little bit, the access layer is where, you know, your users and your phones and your access points all connect. Okay. So this is a traditional core distribution access layer model, but sometimes we don't, or a lot of the time companies don't actually deploy it like this. And what they do is if we put a line down here, demarcation line, and then we say this is traditional, and then we have a collapsed version of this. You might be able to guess what this is going to look like based on the name, but what we effectively do is we combine this layer and this layer into a collapsed core slash distribution layer, like this. And we still have the, you know, the uplinks to the rest of the network, so to the DC, and then the WAN potentially. But what we might actually also have is, if this is a smaller network, we might actually not have the DC split out, and this is the campus LAN slash DC in this collapsed model. Okay. So how the main part of how the infrastructure looks different is that we then just have a collapsed, you know, the clue is in the name, the collapsed core and distribution layer, and then we have multiple, you know, access layer switches or whatever which are connected here, and then we connect the access points, the users, the telephones and all that into these access layer switches, normally via copper. The fundamental reason that I wanted to do this video is because on the left hand side, this traditional model that we're talking about, it's only ever really going to be deployed in very large enterprises who have a big budget, because the simple fact of the matter is it's just not required in a lot of small to medium enterprises. One of the biggest reasons that would drive a full core distribution access traditional type design would be if, for example, let's take this and say we have a core network where, we have different core. Okay, if you think of these core that I'm drawing in, they're then connected to their own distribution switches. So, and then they're connected to the access layer switches like this. And then all the users are connected in here. And if you repeat this model that I've just drawn out, and then say at this core we then have distribution, all that kind of thing, and then they're connected, and then we've got some access layer switches here. What I'm representing here is, for example, a university campus or a large enterprise campus that has multiple buildings. And then if I draw the backbone cabling in red, these might be fibre cables across a campus environment. Okay, so we might have a core which has, you know, this distribution and access layer here, distribution and access layer here, but we also may have a smaller part of the network where we have less users, less servers, where we just have like a couple of switches. So if here we had, like, you know, multiple switches, and you could even have like potentially multiple, well actually that's not entirely true, I'll take that out. If we have multiple access layer switches, then you know, the complexity starts increasing, and it may be that even if I change the font color to blue to highlight this section that I've drawn in at the top, this whole part of the network could actually be one building in the campus. But because if this is the east side of the campus and this is the west side of the campus, you may need distribution switches to service each side of those. If we zoom back down into, you know, the bottom part of the network, so let's just call this the south of the network, and pretend that it's actually its own little building. Let's say it's a lab environment for a hospital or something like that. And it's critical enough to where it needs to have like layer 3 at the core and the distribution layer here, but it doesn't have enough or merit enough switches or access layer switches to have dedicated distribution. So this can be, there's a few different reasons for this. Let me circle back. So the reasons why we might have a dedicated distribution might be geography, and that might be between buildings, or it might just be you have a huge building where you need these separate distribution layer switches coming from the same core environment, or it might be port density, meaning do we have enough ports in here to service the number of access layer switches. So here we have 2 access layer switches, but if these were actually switch stacks, so that's 2 different access layer switch stacks, they're going to look something like this from an uplink perspective if I change my ink back to red. So that's 1 port in this switch here and 1 port in this switch here. We now go, okay, we've got 1 port, another port in this switch here and another port in this switch here. So that's 2 ports in this switch and 2 ports in this switch, plus we've got a port here, a port here, a port here, a port here, and let's just say we had that, for example. So now you can start seeing that like we have 2, 4, 5, or 1, 2, 3, 4, 5 ports. So here, 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 and here, 5 ports in each switch. And if we make this collapsed core and distribution switch, let's say it's a 12 port, each of these are 12 ports, then there's 50% of your capacity nearly gone just configuring your uplinks. So that would be like the port density example. Another example is the geography, where we physically just cannot get these access layer switches directly to these core switches. And then another reason, which is probably the one that's in some of the documentation but isn't actually explained that well, is scaling. So if we scale our environment, and this is probably going to be in larger organizations, but let me paint a picture. Okay, let's say we have 2, and I'll start with a core distribution access core. Let's take core distribution access. Okay, and we've got 2 core switches, we've got 2 distribution switches, and then we have 10 times switch stacks, okay, where that goes to there and that goes to there. And let's say we then go, okay, now we actually need to implement a new hospital wing or something like that in the network, but it's too far away from the core switch to plug in stuff, copper into the cores. It's too far away to plug stuff into these distribution, and then we also have a port density issue. So I'll ask you, what would your solution be there? If this is the west wing and this is the new east wing, the new solution could simply be deploy another pair of distribution switches, connect into the core, and then let's say there's 20 new switch stacks here. Okay, so it goes like that, and then we uplink the access layer. Now let's take that's the core distribution access approach. Let's do the same thing, but with a collapsed core. If we say, okay, we've got two switches, which are the core distribution, and they're connected together, and these are 12 port switches, and we have, so we have, you know, uplink, so that's 1, 2, 1, 2 ports on each, and then we have 6, well, let's say 4 switch stacks. Okay, so there's 1, 1, 1, 1, 1, 1, 1, and this is your access layer here. Okay, so now if we have the same scenario where this is the west wing and we need to add an east wing here, what would your solution be with 20 times new stacks? Well, the solution would be to add a distribution layer again, like that, but we're already at 1, 2, 3, 4, 5, 6. So if they would then say 7, 8, we have our distribution layer. It's not the prettiest design, and then we start adding our, you know, our. Oh, that's not right. We start adding our access layer switches, like this, and so on. Our 20 access layer switches, like that. You get the picture, where we dual uplink them. But let's say now we want actually to add a south part of the network. Here you get the picture. We would add a distribution switch to the core, like that, and then we would add our access layer like that, and you can see we can just basically repeat this distribution and access block. If we do that over here and we say, well, let's add a north part to here. If we say, oh yeah, we'll just put some distribution switches in and then we'll add them to the core, we're now at 10 or 12 ports, close to 10 or 12 ports. So the main part about the scaling aspect, that is one of the key considerations when you go core distribution access, and it doesn't really come into the equation for this discussion whether it's going to be, you know, whether the distribution layer or the access layer is going to be doing layer 3 here or layer 3 here to accommodate for like a new design like software defined access or software defined branch or whatever the different vendors are calling it. The main things that you need to think about in this core distribution access are geography or location, number of ports or port density in the core or the collapsed core distribution switch, which is this design here, and then also how we scale out our network if we have additional requirements from the business. So we started off with a western stack, we added an east stack to the network, and then we added a north stack, and then potentially a south stack. How many ports are available? How do we scale things out? And how also, just the final point on this video is that in the scenario where I added, you know, this with a distribution layer, this other design doesn't have a distribution layer. So another thing that you need to consider to have good network design is consistency. And in that proposed design, consistency was not in any way, shape, or form in place, because one part of the network has a distribution block, and one part of the network has a collapsed core and distribution block. And consistency is key to all network design. You want to make things as repeatable as you can, and yeah, that's what we aim for. So that was my video on explaining the core distribution and access layer model. It's still a model that's out there. You'll see new designs that you have to migrate away from that, but you'll also see similar designs that have core distribution access in the data center, in the campus, even with software defined LAN. There's a concept of a core distribution access. It's just got different terminology, and it's layer 3 to the edge. And yeah, perhaps a bit different in the data center with spine leaf, but that's the skinny. So I hope this video was interesting and informative to you, and if you've got any comments or anything like that, put them in the chat. If you like the video, you want to see more of these, then please let me know. All the best and thanks for your time.